going to show you some of the features in 2021 R2 release of Ansys Mechanical. Let's start with new scripting capability with Python code object. Python code objects will allow automation of analyst calculations, custom parameters, scripting of solver commands, and other custom workflows. This feature can increase your productivity and automate your workflows. This automation occurs through Python scripts that use the Mechanical API and the specification of the object's target callback property. The target callback property defines an event when you want scripts to be executed, such as when you change the property of an object or following the solution process. Python code objects enable you to create custom properties that can be parameterized. These parameters can be used to then update the values of other objects, for example, loads and boundary conditions, through the Mechanical API. As shown here, a script automatically updates the pretension load value for a set of bolt pretension objects with one entry. If your model includes a surface body, the new Mesh Object Feature pool enables you to extrude or revolve the body to create a 3D solid body that is meshed. You can then use these mesh bodies in your analysis. For example, you can create a 3D sector from a 2D surface body using the Revolve option and then perform a cyclic symmetry analysis. The ability to create a volume mesh from a surface mesh is beneficial for the design and simulation of structures such as turbo machines and printed circuit boards. It is common to first design a base surface, as it is easier to generate a surface mesh, and then to extrude a small layer of the volume elements from this base mesh. Next is the Multistage Cyclic Symmetry feature. Mechanical now offers a way for you to combine two or more independent cyclical symmetric systems that have different sector counts in one multistage analysis. This feature utilizes the stage and interstage objects to connect multiple cyclic region or pre-mesh cyclic region objects. By connecting multiple stages together, you can leverage the efficiency and accuracy of the cyclic symmetry procedure to simulate structures with several cyclic parts, such as gears, turbines, and turbo machinery in a single multi-stage analysis. In addition to supporting a coupled structural acoustic analysis, you can perform a purely acoustic transient analysis. Using a coupled field transient acoustic analysis, you can simulate a fluid region only and ignore any fluid structure interaction if the physics region is set to acoustics only. This enables you to study the dynamic behavior of the fluid region. As shown in our example here, an acoustics boundary condition and acoustic excitation are applied, and output pressure distributions are examined. Mechanical now provides a new option that provides a general estimate of the computational resources required to solve a selected analysis. Selecting this option opens a window from which to specify a desired system. Currently, only standalone static structural and modal analysis systems are supported. Knowing whether your analysis will take a considerable amount of time enables you to manage your time more efficiently. For static structural systems, estimates are performed for the direct and iterative solver settings, and for the modal analysis, only the direct solver setting. For static structural system, this information enables you to make a more informed decision for the selection of the solver type property. For 2021 R2, the LS-DYNA system in Workbench has been enhanced to provide setup, solve, and post capabilities for arbitrary Lagrange Euler, also known as ALE, and structured arbitrary Lagrange Euler, also known as SALE, directly in Ansys Mechanical. This new implementation supports ALE domain definitions, mesh creation, coupling control, ALE-specific material models, and boundary conditions, as well as custom post-processing results. This gives you unprecedented ability to model extreme deformation and plastic flow of material, and opens exciting new possibilities in applications like bird strike and blast. The LS-DYNA system's restart capabilities are also a significant enhancement to allow new parts to be introduced into the restarted systems, making preloading significantly easier and more powerful. You can now directly link the solution cell of an Ansys motion system to a harmonic acoustic system. In this axle model, an electric motor and a drivetrain are contained within a flexible enclosure. You can import the electromagnetic forces that drive the motor from a Maxwell analysis. These forces produce the necessary torque to drive the gears. Following the solution, you can then view the motion of the model caused by the forces, as well as view the deformation of individual components of the enclosure. The ability to link Ansys motion to an harmonic acoustic system enables you to transfer structural velocities and to simulate the acoustic pressures generated by the vibration of the assembly on the surrounding environment. Be sure to download the latest release from our customer portal and check out our website for more details on 2021 R2. Thanks for watching!